Hello, I am here today to make a coding challenge about making a perfect, well, it won't, whatever I make won't be perfect, but you might make something perfect, GIF loop. So what is a GIF loop? Why am I talking about GIF loops? So one way that artists who work with computational media and computer graphics are distributing their work and expressing themselves is through posting GIFs to various different online platforms. An artist I would like to highlight is saveFrame, who has been making daily animated artworks for quite a long time. In fact, maybe there have been at least 1,500 of them, which is mind-blowing. And you can see a whole variety of them here on her Tumblr. There's some other, I think she wrote a Medium article about this process. They're amazing. A very famous GIF artist that I have referenced in previous videos. In fact, I did a whole coding challenge trying to recreate his cube wave is Bees and Bombs. So Bees and Bombs creates looping GIFs through algorithms and math and graphics in all sorts of astonishing, mind-blowing ways. So I encourage you to check out Bees and Bombs. Also Tumblr to see all of the kinds of GIFs that he has created. Golan Levin at Carnegie Mellon University, a professor at Carnegie Mellon University, gives an assignment every semester in his course, Interactivity and Computation, to create a GIF gallery. And so to create a GIF. And this is a gallery of GIFs that students made in his course just this past fall. And Golan has a lecture about loops throughout the history of art. You know, it's very easy to think as we work on programming the computer and make algorithms visual and happen in JavaScript in the browser with your OpenGL shaders, WebGL magic, that this is the first time any of this has happened. But this kind of work has been happening for years and years and predates the dawn of computers themselves. So this is a wonderful set of historical references to different kinds of loops that people have been making. And of course, here's the iconic Muybridge galloping horse that you can see here. So I encourage you to check out all of these resources, read about loops. And in fact, you don't even need to watch this video. You can go right here to Golan's loop templates, which has templates for processing Java, P5.js, JavaScript, and Python processing as well. So what I'm going to do, though, in this video is I'm going to make my own. I'm not worrying about making something artistic or innovative or beautiful. I'm just going to try to show the process from start to finish of writing code and processing, rendering it out to files, and then packaging that up as a GIF that you could post. I'm also going to come back and do a follow-up video. There's a new P5 JavaScript GIF library that some students of mine worked on last semester in a course about open source. And so I will come back and show that in a future video as well. So let's get started. So what is the driving principle of making a loop? So if you look at Golan's code examples, the core idea is to have first a total number of frames. So a GIF, an animation, is just rendering a whole bunch of images in sequence at some frame rate for your eye to see, and it appears like animation. And if whatever it is in the last frame, or really what would be the last frame, the sort of like frame before the last frame, matches up exactly with the first one, then you have a loop. So in other words, if I'm drawing a circle here, and then it goes to here, and then it goes to here, I don't need that many frames. And then it goes to here, and then maybe it disappears. I have a blank frame. Then, in theory, the next frame I want to see would be it entering the screen again, but instead I go back and show the first one. So this will look like it's a loop that's going on forever, whereas in reality, it's just starting at the beginning, and the last frame matches that. And so as it goes back to the beginning, it appears infinite. So this is the idea. So couple things we need to do. We need to keep track of what is the total frames we want. And then I also want to have a variable called %. And the idea is that % will always be the current frame count, will be the current frame number divided by the total number of frames. And what you'll see in Golan's example, let's do the same thing, is if we have the ubiquitous processing draw loop, draw is looping over and over, we could actually put our code somewhere else. Like maybe I'll write a function called render, and we would just call that function render passing in the percent. So this is a function that knows how to render some kind of design based on what percentage of the way through the design it is. And as long as the design is thought of in a way where the end matches the beginning, then this is going to work out. And all the other stuff about like saving frames and all that kind of, is it recording, is it not recording, that could be in the draw loop. Okay, this is way too much explanation for something that's in essence like quite a bit more simple. All right, there's two more things I want to say about this. One is Golan writes in his instructions to his student, sketch on paper first. So I really recommend you do that. If this is something you want to create, try working this out with crayons, markers, charcoal, pencil. That's a really helpful, going into that sort of like analog drawing process will really help you think through your ideas. Number two is, what are the kinds of algorithms that move a value from one number to another number, and in fact maybe like wrap back around. And there are all sorts of different kinds of ways of doing this. Probably if you've watched any of my videos before, you might be thinking of the sine function. The sine function is an excellent function to use for a GIF loop, because if it the sine function, if I were to graph the sine function, right, where it starts, it repeats. It's a repeating pattern over and over again. You could also use, and then there's a ton of different kinds of easing functions. So there's this lovely website called easing functions, easings.net, which is an easings function cheat sheet. And I highly recommend you explore some of these other easing functions to think about how you might move a value through this loop. And if you go to Golan's code, I'll just click on the processing one for a second. You can see, like, even in the code here, there is a this like double exponential sigmoid easing function. So anyway, that's a like exploration you can do separately from this video. Let's just get the basic mechanics working. All right, so I have a blank processing sketch now, and I'm going to go add setup. I'm going to draw. Let's make it a square, like 400 by 400. Let's make the background 0. But no. Let's make another function called render. And this function is going to take a value like percent. And what I'm going to do is I'm going to say render percent. I'm going to say the percent is I'm going to make my own variable called counter divided by the total frames. So this means I need to say, like, okay, well, I want to have 120 total frames in this GIF. I want to have a counter equal to 0. And now here, what I'm going to do, let's just do something like, say, the ellipse. An ellipse is at percent times width. This would be a linear function now at height divided by 2, and which is like 20 by 20. So we can see now, if I say counter plus plus, and I'm going to say float counter, let's just see if this works for a second. So this is the idea, that I have a total number of frames, I have a counter that's going to go up, and I really want to, after I want to start the counter at 0 and then count up by 1 after render. And the idea here is that a much more complex, sophisticated design with all sorts of different kinds of easing equations could be in here. But let's just see if this works. I have some brackets out of place. I have some weird extra slash here. So let's see what happens. There we go. So we can see it's moving across. It's almost like the ball is moving because it's being drawn based on a percent. Now, how would I determine how I want to render this? So if I'm I'm just going to have mine start recording right when the program starts. So if you look at Golan's example, it's a bit more sophisticated. You press a key, it starts recording. But here what I'm going to do is I'm just going to say, right here, save frame GIF dash pound, which are hash, PNG. And I'm going to make a folder called output. So what this function does is it saves an image to the directory output associated with this processing sketch as a PNG. Those hash symbols or pound symbols indicate to processing that you want the file name to be numbered based on the frame count. I want to use my own counter. This is going to use the automatic frame count, which is probably fine. But what I want to do is I'm going to say plus number format counter 4 plus PNG. So I'm going to add the counter number in here manually. I think that's going to be a little better. This number format function says use 4 digits no matter what. I guess I can just use 3 because I know I'm going to I'll have 120 frames, only need 3. .png. And then what I could say is if counter equals total frames, I'm going to just basically say exit here. So I'm going to tell the program to stop. So let's run this. Okay, now let's look. I have a folder called output. I look in there and we can see, there we go. I have all my images. So there are tons of ways now I could take this and stitch it together as a GIF. So I'll show you how to do the stitching later. In fact, this new P5 library actually will just create the GIF for you. But it's kind of nice to have them as separate images. And we do have this question of like, do I have it matching up correctly? Like we should see the last one should be 119 and it's there. So my algorithm is perhaps like not the best. Like really like this percent times width isn't really like a perfect loop. So that's something I might need to improve. But let's make something that I know will be a perfect loop. So for example, one thing that I could do now is I could say, all right, let's use rotate. So I'm going to say angle equals percent times 2 pi. And I'm going to translate to the center of the window. I'm going to say rect mode center. I'm going to say no fill, stroke weight 2, and then I'm going to say rectangle at 0, rotate by some angle, rectangle, let's use square, square at 0, 0 with a side length of 100. So let's look at this. Ooh, what just happened? No fill, stroke 255. And this should have a fill of 255. So now we can see this is spinning. Now in theory, that's going to match up perfectly because that rotation at 2 pi equals the rotation at 0, and I'm rendering the very last frame right before percent would be 1, in which case it would actually be 2 pi. So this should match up perfectly. Let's now, I'm going to comment this out. Let's do this one more time. Let that spin. Stop. Now let's actually make it a GIF. All right, so now that I've made all those images and saved them to the output folder, I'm going to try stitching them together as a GIF. I'm using this website called EZGIF.com. It must be easy because it says so. So I'm assuming this is going to work great. But there's lots of other ways. You can use Photoshop. You can use FFmpeg. There's all sorts of different tools, software tools that you can use to stitch images together into a GIF. But let's see what happens if I select Choose Files. Luckily for me, it's already going straight to my output directory, but you'd have to find that on your through your Finder or whatever operating system you're using. I'm going to do Select All. I'm going to click Open, and then I'm going to say Upload and make a GIF. And this is going to work, right? Oh, look. So we can see, look at this. We can see all that. The delay is 20. So 20 milliseconds would be, I guess that's like somewhere between 30 and 60 frames per second. And somewhere here, I should be able to say, I can change the delay time. So 60 frames per second would be like 16.7. Let's just leave it at 20. Loop count, loop forever. I'm not going to cross-fade frames. What's interesting that it has that effect. Let's try this make a GIF. Oh, I have to wait now. It's baking in the oven. Okay, it says right there on the page, in 1/100th of a second. 1/1000th of a second is a millisecond. So like 32 milliseconds of delay is like maybe around 30. Let's make this 3. We want 3/100th of a second. Let's just try that. Let's see what happens. I mean, you might want it slower, but I want it to kind of like look like how it looked in processing. So let me click this again. There we go. Look, there's my GIF There's my GIF. Is it perfectly looping? Sort of hard to tell, but now I should be able to download it. I can probably just like right click and do save image as and say, put it on the desktop. Yay, I made a GIF, I made a GIF, I made a GIF. Okay, so you get the idea. Oof. All right, so, ultimately, the creativity of what you design is really the thing that I'm hoping that you will discover in yourself to make something. I mean, I've just made a rotating square. But I think in order to be able to explore your creativity, you're going to need the tool you're working with to be a bit more flexible. Because right now, the way that I set this up is it kind of runs it once and then quits. But I really want to be able to watch the thing loop and then like change the code and run it again and change the code and run it again, and then when I'm ready, kind of hit record. So let's do that this way. I could do that through an interface, but I'm just going to make a Boolean variable called record, and I'm going to set that equal to, right now I'm going to set that equal to false. Okay? So what I'm going to say here is if, I'm going to say float percent equals 0, and this is very similar to Golan's. If record, then I am going to use this counter that I have, and then I am also going to do all this stuff like saving the frame. Otherwise, I am just going to say percent equals float, the actual frame count. I mean, I could always use the counter. This is silly. I should just always use the counter. But frame count modulus total frames divided by total frames. And so this should really be, this is a little bit goofy, but I'm going to put the percentage around here, the parentheses around there. Okay? So let me give myself a little bit more room to look at this code. This is weird. I gotta explain this for a second. And why? There we go. Okay. So what I want to do here is I want to have the frame count always cycle back to 0, and I want to, which I use the modulo operator, and then I want to divide that by total frames, but I want to convert that into a float, and so I don't need these extra parentheses or this parentheses. Yeah, no, yes, this is what I want. Ah! I will refactor this later, All right. So now that recording is false, this is just going to play the loop forever and ever again. And I know that if I ever want to now record it, right, if I like my design, I can go and delete what was there before, which I don't have to. It'll overwrite it. And I can change recording to true, and then I can run it. It will do the recording, and then it will quit out. You know what? There's a mistake here. I am recording the last frame, and I don't want to. Let's look at the output here. Yeah, 120. I don't want 120 because 119 is the frame right before the starting frame, the way that I've coded this. So this save frame has to be here. So that's a quick fix. Let me delete that again. Let me run this. Here it goes, record. It's going to draw that last one, but that's fine. Now we should see the very last. Shouldn't it exit before it does that? All right, well, let's do it this way. Let's just check if it gets to the end. If it gets to the end, the frame before the last one, then quit. And now, here we go. That worked. I can see just based on where it stopped. Okay, great. So this is what I want. I want the last frame to match up before the first one. Okay, great. So there's so much other stuff we could do. I could use like a sine wave. Again, I would encourage you to look at different easing functions and try all sorts of different kinds of designs. And your only limitation for yourself is that the end matches up with the beginning. But matching up can mean a variety of different things because something can leave the window and then enter again. So as long as there's a visual continuity, your GIF will loop. So I will come back. I will show you also how to do this in P5.js in the browser with a special new P5 GIF library that I've been testing thanks to the creators of that library. And I'll come back and show that to you in a future video. And please, share your GIF loops. We're going to have them all over the place. I don't know. Coding train GIF loop. No, what should it be? Just share them. Just look at this video's description. I'll explain how to share them. Goodbye. Thank you.